Alright, so this is lesson 2 for unit 8. We're going to talk about normal distribution. So the first thing we're going to look at is data. Remember that data is just anything that's information. Okay, so like, you can have different types of data. You can take data from like the heights of people, or if you're measuring something. It's just as long as you have all this data together. So data is facts and statistics which is collected together so that we can analyze the information. Data can be distributed. In other words, it can be spread out in different ways. Okay, so here are the 4 different ways we're going to look at. It could be spread out more on the left side, meaning that even though it looks like we have more data on this right side here, but it's more spread out on the left side. We call this a left-tailed. It kind of gets spread out over here. Okay, looks like a little tail here. Or it could be right-tailed. Data could be spread out more on the right. The data can be all mixed up like this. Or this last one, which it will be focused more on, it could be symmetrically distributed. Okay, it could be more towards the middle, and it'll have a left side, and then it'll have a right side. It could be a left-tailed and a right-tailed. Okay, so this is when we have data like this, we call it a normal distribution. Okay, it's normally spread out. It has a normal distribution. And so in Algebra 2, we will focus on the normal curve. We will focus on the normally distributed curve. Okay. All right. So over here we have the normal curve has the following characteristics. We need to know that the mean is always equal to your mode and median and your mode. In other words, to say mean is average. The curve is we call this a bell shape, okay, because it looks like a bell, okay, and is symmetrical. It is symmetrical about the mean. When it says about the mean, it means on either side of the mean, which means that the mean goes right in the middle, meaning the average, and it's symmetrical on the left, symmetrical on the right. The curve never touches the x-axis. The total area under the curve is 1 or 100%. Okay? And then the empirical rule, this rule is important and you need to know these numbers. If you're 1 standard deviation from the mean, it's 68%. 2 standard deviations from the mean is 95%. And 3 standard deviations from the mean is 99.7%. So we're gonna practice how do we label. We need to represent each of the following distributions on a normal distribution graph, or each problem it should say on each problem show the 3 standard deviations to the left and 3 standard deviations to the right of the mean. So what we're going to do is you're going to be given 2 pieces of information. You'll be given the mean, which I'm going to say mean is equal to 7, and the standard deviation is equal to 2. Now these 2 symbols, they're Greek symbols. This mean here, this is a lowercase m in Greek alphabet, and this is a lowercase s in Greek alphabet. Okay? So what we do is we take the mean, which is in the middle, and you put it right in the center, which is at 7, and you have the standard deviation, which is 2. So what we do with the standard deviation is we count by 2. So if it's 7 plus 2 is 11, plus 2 is 13, plus 2 is 15. Okay, and then same thing on the right. Now you're going to count by subtract 2's here. So you're going to have 7 minus 2 is 5, minus 2 is 3, minus 2 is 1. Okay, so that's how we set up your standard deviations. It's always basically we're counting by whatever the standard deviation is. Problem number 2, same thing here. The mean is at 500, and then the standard deviation is at 100. So you have 500 here. If the standard deviation is 100, so you just add 500 plus 100, 600, 700, 800 to the right, and then 400, 300, 200 to the left. Okay? Same thing here. So you have 65. Oh, sorry. The mean is at 80, 800, and then the standard deviation, which is at 65. The mean is at 800, and then the standard deviation 65. So you do 800 plus 65. I'm going to use a calculator. So you do 800 plus 65 plus another 65 is 930, plus another 65 is 995, and then 800 minus 65, 735, 670, and all I'm doing is subtracting. I'm just counting by standard deviations. Okay? Alright, so now I'm going to look at these 3 problems over here. Okay, so this one is saying, just to represent the data, so the mean is 101, so it goes right in the middle, and then now you're adding 102 standard deviation. So you're going to do 101 plus 1.2, which is 102.2 plus, so let me just finish. Okay, so here we go. I did all the math in my calculator and wrote out that. This one is saying the length of a private in our army is, well, I don't really care about what it says. I just want to make sure I find the mean. So the average is another way to say mean. Average is 1, and then the standard deviation is 0.3. So I would do 1 plus 0.3. So you have 1 in the middle, and then 1.3, 1.6, 1.9, and then 1 minus 0.3 is 0.7, 0.4, and 0.1. Okay? And then it's saying shade the area under the curve that represents the probability of length within 3 standard deviation. So we count by standard deviation. This is 1 standard deviation, 2 standard deviation, 3 standard deviation. So it's asking us to shade. Let me get a little highlighter here. It's asking us to shade from here all the way until 3 standard deviations. Okay? And over here, if we go back to the first page, it tells us that if we are 3 standard deviations from the mean, you're at 97%. So that's basically what this question is asking. You are at 99.7%. Okay? And then here, we have to first get the numbers. So here it says the mean is at 30, and then the standard deviation is at 7, and then so we have 30, 37, 44 plus 7 is 51. Okay, and then 37 minus 7, that's 23. Let me just use my calculator. 23 minus 7 is 16, minus 7 is 9. Okay, it's saying what is the shade the region of the probability between 23 and 37. So 23 is right here, 37 is right here, which means that I'm going to shade this area over here. Okay. And then now we're looking for this area right here. It says what is the percentage. So now we're going to go back to our chart here. If you're within, it looks like we were within 2 standard deviations, which was at 95.4%. Okay, so actually we weren't within 2, we were within 1 standard deviation, which was actually at 68.2%. Okay, 68.2% if you're within 1 standard deviation. Okay. So now I'm going to show you how do we do standard deviations in the calculator. Okay, so here we have that the mean is at 80, and then you have a standard deviation of 5. Okay, I'm just going to go through these 3 problems first. Okay, it says, so there's 3 different problems, 3 different type of problems you're going to have. You're going to have a problem that says between 2 numbers, or it'll say more than 1 number. Sorry. Oh, get out. Or you would have less than. Okay, so let's do the one where you have between 73 and 80. So from the previous page, we saw that the mean was at 80 and the standard deviation was 5. So I'm going to just count by the standard deviations. Oops. So this is at 85, 90, 95. So this is 85 minus 5, that's 75, 70, 65. So it's asking us to find the percentage between 73 and 87. So 73 is somewhere over here, and then 87 is somewhere over here. Okay, so it's not exactly falling between the standard deviations, right? So which means that we have to use the calculator to find that percentage now. Okay, to do that we go to our calculator. I have the steps on the page on the previous page, but I'm just going to walk you through it. Okay, so you see over here it says distribution, so that's what we're going to do. We're going to go to second, distribution. Then we're going to go to normal CDF. It's always the second one. Hit enter, and it's going to ask you for 3 questions. It's going to say, what is your first number that you're starting at? So you're between 73 and 87. So those are the numbers I'm going to put in my calculator. 73. And then you have 87. And then you have between, the mean was at 80. And then you have your standard deviation of 5. And then you hit enter a bunch of times and you get your answer, which is at 83%. So the calculator will always give you the probability, so you just write the decimal, okay? And then percentage is basically where you move your decimal places over to. So this is about 83.4%. Okay, and then here when you have a problem where it's saying more than 83, so we know that 80 was over here, and then 83 was somewhere like between 85 and 83, so this was 85, so somewhere over here. And if you're saying more than, you know that you're looking at on the right side from here. Okay, it's on the right side. So here it's actually starting at 83 and we're stopping at infinity. We're not really stopping because it actually goes on forever. So in my calculator, what I'm going to do is second bars again. Always choose normal CDF, and your lower is your starting, which is at 83, and then your upper, which is at infinity. Okay, infinity in your calculator, you can put like a really big number. I don't know, you can put like like a few zeros there, and then the mean and the standard deviation stay the same, and you hit enter and you get your answer, which is at 0.27, or you can say 27%. Okay, and then, but just make sure you put a bunch of zeros here. Okay, and then the last type of problem you have is a score less than 64. Less than 64 would be, so you know that so we had 80, 75, 70, 65. So 64 is somewhere over here. This is 64, and we're looking at a score less than 64. It's actually a tiny little percentage right here, tiny. So we're gonna put that in my calculator. We're gonna go to second distribution. We're gonna do normal CDF, and then hit enter. So your lower number here is going to be that negative infinity. Okay, so you're going to put -1 and then just put a bunch of zeros, as many zeros as you can. Okay, and then on the upper will be at 64, and then you just calculate it, and then it gives you your answer right here. So you're gonna put this e to the -4. Remember, it tells you. Let me write it out. So this is actually in scientific notation. E to the -4 tells you to take your decimal place and move it over 4 places, which means that you have 0, 0 here. So this is actually your probability right here. Okay, so which is a percentage of, move the decimal place over 2, so this is 0.06%. It's a tiny little percentage. Okay.